Okay, so good evening everyone, and welcome to our short session of today about blockchain. I will just go briefly on the agenda. So first I will start by introducing myself and the company I work for, which is F6S, and then give you an overview of this type of projects that brought us here today, okay, the Erasmus projects. Then I will give the floor to our guest speaker, Paul, and then it will come back to me to talk you through the course that we have developed in the scope of the Beside project. So, first things first, my name is Marina, and I'm here today with my colleague Carolina. We work at F6S. I work as a communication and project manager, and Carolina is a project manager at F6S. So what is F6S? You probably never heard this. Our company basically tries to connect people that want opportunities like investment and more knowledge to accelerate the growth of their companies, startups and SMEs, with people that have the power to provide them with funding, knowledge, and other perks. We have currently in our platform, in our F6S platform, we do this on our F6S platform, we have currently more than 4 million enrolled SMEs and startups looking for opportunities. And we have more than 4,000 corporates wanting to give opportunities to them, okay? We also have a scouting team that connects these two parties. But we also have these startup programs, as you can see here. This is, you can access f6s.com. And you can search for all types of opportunities to if you're a student, if you are a university student, if you are starting, if you have an innovative idea, for sure you will find something that matches up with you and that can connect you with funding, knowledge, the right ecosystem to advance your company. Here are the corporates. Some of them are very well known as Vodafone, Barclays, you know. They're all in our ecosystem and eager to help our founders grow. But then me and Carolina, we are in a very specific part of F6S, that is the one that works with European projects. So we contribute to this ecosystem by managing projects that are funded by the European Commission, okay? And these projects basically are to advance research, sustainability, agriculture, manufacturing, AI in multiple areas and with multiple types of offerings. Money, it's one of the biggest ones, but then again, knowledge, ecosystems to make the companies grow. So we do all of this. And inside European projects, there are a lot of types of European projects, okay? We manage some of them, but one specific type is Erasmus projects. Erasmus projects are are targeting mainly youth people, young people, and providing them with knowledge to advance their skills in a certain area. So all of these Beside projects, these are all managed by F6S. All of these Erasmus projects have the objective to create an e-course in several areas, in different areas. This one I'm talking today is about blockchain. And then people can take this e-course on their own. Okay, it's a self-taught course that usually brings them from the scratch, from the basic concepts of whatever topic we are discussing, and to more advanced ones. Okay. And we have projects in many areas, but I would like to catch your attention to these two specific projects, which is Beside, the one I'm presenting today, but also B. B is also a project that we have ongoing. It's a different topic, totally different topic, but just bear with me for 2 minutes. I'm presenting it as well, very, very briefly, because maybe you have someone that is interested in this opportunity. So B is in the area of blue economy. It's basically for sustainable tourism. So if you know someone that works in tourism, especially coastal area tourism, this might be a good course for them to have more skills on how to turn their business in a more sustainable business and more compliant with the environment and all of this stuff. Blue economy is with everything that relates to sea, oceans, and coastal areas. And then again, they created this amazing e-course for entrepreneurs in tourism that, you know, have multiple subjects here, even finance. If you see the last module goes into financial resources. So if you know anyone interested, that tell them about the BE course, might be cool for them. But I will not take more of your time on this. And now let's just talk about what we are here to talk about, which is my project Beside and blockchain. And for that, I will give the floor now to Paul to tell you a bit more about blockchain.
So this is a very brief introduction to blockchain. What it is, what it's about, what it does, what it doesn't do, and a little bit about what it might be used for in the future, and then where you can learn about it. So why am I here in front of you at the moment? My name is Paul Hearns. I'm an author, journalist, and currently a content consultant. So I help large technology companies express why they do what they do the way they do. I've been in or around it for a long time. I edited Ireland's Professional Journal for 15 years, and I am a fellow of the Irish Computer Society. So, what is blockchain? Put simply, blockchain is a distributed system of record where actions are recorded by consensus and once added become immutable and accessible to all. So what does that mean? Blockchain is a database, but it's a database that lives in everywhere at once. It's an open system, which means everybody can run a node of a blockchain network, and before another block gets added to the network, everyone has to agree that it went through the right processes to qualify, and that once it's then added to the block, it's updated to every block and everyone can see it. So this is it. Each new block is digitally connected to the others previously, and each node in the network is updated with it. So if you think of a node as a copy of the database, all the copies are linked together, and then the consensus mechanism makes sure that each block that's added is of the right quality and meets the criteria necessary. So the other key point then is that this is designed to be a zero trust system. So it means that you don't have to log in with an identity. It means that you have a basis for the criteria to be met that works on a zero trust principle. So what that means is it's not based on a password, it's not based on an ID, it's based on a set of criteria. And once those criteria are met, the whole thing works on. Which is why there are so many questions in terms of security and identity around it, but we'll come to that as well. So blockchains are a zero trust system. So it doesn't rely on identity or credentials as such in the same way as other databases do. It's secure in that once something is accepted onto the blockchain, once it's met the criteria, it's immutable. It will not change after that. It's also open and readable by everybody. So it means that even though IDs might be associated with a block, it's not necessarily a person's name. It could represent an asset token. It could represent a digital wallet. It could represent an individual. But that itself is not recorded on the blockchain. What's recorded on the blockchain is the criteria of creating that block, and that varies depending on the application. So as I mentioned, it's immutable. Once it's on there, it's unchanged. And it's distributed and decentralized. So what that means is that decentralization means there's no one server that the others all follow. Each node is individual, and each node has the full capability of everything else. So it's highly resilient. You could take out large sections of it and it will still function just as it always has done. But what it also means is that there's nowhere to hide. Because it's open, all transactions are available. So essentially, it's a network of computers that can run these nodes. Most common example that people are aware of, Bitcoin. You could run a Bitcoin miner on your phone, which means that the transactions you process could potentially add to the blockchain from your phone, from your laptop, from a server, or, as we've also seen, from a giant data center that's putting hundreds of teraflops of processing capacity behind it. But it just means that it's a network of computers, much the way that, say, the internet is at the moment. So as I said, the blockchain will have a set of criteria by which a new block can be approved. And this is known as the consensus mechanism. So it's the consensus that all criteria have been met for a new block to be formed and for that block to be digitally attached to the blockchain. And that's how it runs from there. So in terms of technicalities, the actual blocks themselves can be anything from about 4 megabytes up to 12 megabytes. So there are different networks depending on what you're talking about. Bitcoin is the most common one. One of the other common ones is Ethereum. But as we'll see, it really depends on the application, because a blockchain system can run behind lots of different things way beyond cryptocurrencies. So as I said, when a new block is added, it becomes part of the network, it becomes visible to the entire blockchain, and it's immutable and cannot be changed, which is why it's now being applied in so many other different areas. So the functionality of a blockchain can be extended by smart contracts. So in much the same way as a database is not much good unless something actually interacts with it and uses the information that's in it, a blockchain is a repository of information and transactions. So a smart contract is a programmable set of criteria that can be triggered automatically as those criteria are met, and it can set a number of actions in motion. So digital contracts, or a smart contract is a digital contract that can be stored on the blockchain and automatically executed for a predetermined set of outcomes. So say, for example, it just means that all parties to the contract can be sure that when the contract is executed, what the actual outcomes are. So it's not dependent on variable conditions. Once the conditions are met, the contract does a specific thing and everybody knows what's coming out the other end. So it can be used to automate workflows and trigger a number of predetermined actions as well. So again, given that blockchain technology came out from a cryptocurrency, it still brings with it a lot of the kind of financial criteria and financial features that you would associate with a currency. So it's very good at following a transaction and allowing those trigger points to be met. So it's not necessarily like a kind of a typical business contract. It's much more kind of financially inspired. So where did blockchain come from? Blockchain came from the system behind Bitcoin by this guy, Satoshi Nakamoto, in 2008. Now, nobody's quite sure who this guy is. Some people presume it's a made-up identity. A lot of people have been accused of being him. Some have claimed to be him. Nobody's actually sure. It's not the point. The point is Bitcoin is here, it works, but more importantly, blockchain as a system has grown far beyond Bitcoin and cryptocurrency generally. But it didn't come out of nowhere. These other two guys, Haber and Stornetta, they had been talking about a cryptographically secured chain of data blocks as early as the early 2000s. So again, in the usual way of these things, an overnight success in technology usually has anything up to a 15 or 20 year sort of cycle of development before it got there. So this didn't come out of nowhere, but it was unusual insofar as a fully formed system to come out like Bitcoin almost out of nowhere is quite unusual. So what are the disadvantages of blockchain? First of all, blockchain can be hard to scale. So if you think of a platform like, say, something common like eBay, or say the Amazon retail system, or if you go to the other end, something like a financial trading platform, they can be measured in tens or hundreds of thousands of transactions per second. So blockchain in its current state generally doesn't work that way. It takes a lot of processing power, it takes a lot of network connectivity to make it work. Now it is getting there, and there are developments in it, and we'll come to some of those technical developments there, but at the moment it doesn't scale in those ways. Transaction costs, or what's referred to as gas fees, can be high compared to other platforms too. So that's just the actual cost of going across the network, processing a new block to actually be added to the chain can actually be quite costly. Usability. So blockchains are not designed with graphic user interfaces. They are not easy to use. So whether you're building a blockchain for a specific purpose or plugging into one to use its features, it's technically quite challenging. You would need to be a coder or technically adept at some level. Now that is changing, and blockchain as a service is being added to things like the Amazon Web Services platform, AWS. It's on Microsoft Azure. It's on many of the big cloud platforms. And there they are working hard to put those kind of wrappers around it so that it's point and click and you can work it. But it's just usability at the moment is one of the key areas. Interoperability is an issue as well, and particularly if you're trying to go across blockchains. So most of the applications at the moment have generally been in a single blockchain system, but when you try and connect two different ones, then it can become challenging. It's also energy intensive. So blockchain, when it developed behind Bitcoin, was based around a system called proof of work. And what proof of work meant was that you had to perform a certain number of mathematical calculations before you achieved a threshold level that was part of determining whether a block could be added to the chain or not. And that was vast, vast energy usage. So much so that in some areas, old power plants were actually commandeered to host Bitcoin mining operations. It was that intensive. Now, there is a different system called proof of stake. And what that means is that it's a system that doesn't look at the processing you did, it looks at the outcomes you got from that and where they can go. That can offer up to a 99% energy saving compared to a proof of work system. So the Ethereum blockchain system moved to a proof of stake system. And when you have a major change in how something happens like that, it's called forking. So there was a fork in the Ethereum network that went to a proof of stake, and immediately their energy levels went down dramatically. Their costs went down significantly as well. There are different types of blockchains. So there's a public blockchain, as in the Bitcoin network. Anyone can go and set up a Bitcoin blockchain node and begin the processes to work in it. So essentially, you can mine Bitcoin by simply running the algorithms to try and create a Bitcoin yourself, or you can participate within the network, validating all of the other transactions that are happening there to make sure that the consensus mechanism is working. And by doing that, you can be rewarded in blockchain or in Bitcoins yourself. So that's a completely open public access network. So then there are private blockchains. So say, for example, one of the applications we'll come to shortly is in the logistics space. So the giant shipping company Maersk, they worked with IBM and they developed a blockchain system themselves purely for managing the logistics of the hundreds of thousands of containers that they ship each and every day. Then you get a hybrid blockchain, which is a mix of both. So that can be where part of it is open and part of it is permissioned, and it can work in both ways. So that feeds then into a consortium blockchain. So that's where a blockchain might underlie an ecosystem or a sector. And this is something where blockchain is really being applied. So blockchain in the medical space, blockchain in the pharmaceutical manufacturing space. So that would be where, say, a company that is the basis of an ecosystem uses a blockchain system for record, and other partners, vendors, customers are able to plug into it. But you're only able to plug into it in a certain way to achieve a certain outcome. So say a vendor into the ecosystem doesn't necessarily have the same set of features as a customer to the ecosystem, but they're both using elements of the blockchain for the verification, for the security, for the immutability elements of it. You may also have heard of what's called layer 1 and layer 2 blockchains. So this is part of the kind of scaling solutions for it. So when they're looking at what blockchains can and can't do, when they're trying to increase overall performance, when they're trying to simplify what they're doing, there's different kinds of things they can do. So there's layer 1 and layer 2. So we won't worry too much about those at the moment, but essentially what they do is they take some elements of what they're doing offline, they kind of bundle them, process them together, do maybe 10 or 20 types of a single task, roll it up together, and then put it back into the system. And it's just, they're ways of improving throughput and increasing efficiency. But they're all just kind of sub-processes that feed back into the overall. And they're worked under layer 1 and layer 2. So what is blockchain actually used for? So identity management, credentials management, land registries is emerging as a major one, health records, supply chains, as I just mentioned with Maersk. Insurance is a big one. So the immutability element of, and the consensus mechanism of a blockchain is ideal for the insurance world. So once you are run through one of these verification processes for an insurance company, once that's established, that can be added as a block to a blockchain, which means that it never has to be done again. The credentials and the detail is all there. So you are now an entity within a system and you can be processed. So it means then that you can release back to the client a lot of the processing that you would have had to have done yourself as an insurance company. That applies in terms of health records as well, and it applies in supply chains. So there's a kind of it's like opening up a self-service element there, because once something is recorded and identified on a blockchain, it doesn't have to be done again. So carbon management is another big element there as well. So there was a big scandal. The Guardian led a consortium of investigative reporters who established that a lot of the carbon trading and carbon credit systems that were being used by large international companies were essentially fraud. They didn't work the way they said they would. Carbon management systems that are based on a blockchain are much more secure, they're much more transparent, and once they're recorded, again, immutability, it's there for everyone to see. So it's an ideal means of doing that. Decentralized finance is another big one. So again, one of the big things with blockchain is the undisputed nature of the record keeping in it means that it's a very high level of trust. So decentralized finance works by removing intermediaries. So instead of, say, traditional type finance whereby somebody might have to go to a bank or a large fund, take out a lot of money, and then begin to divide that up for smaller purposes. So say, for example, investment managers, things like that. So if you have 100 people who all want a relatively small amount of money, the processing overheads for that could be very large. Whereas if you have a blockchain behind these things, it can immediately reduce the intermediary level necessary and it can reduce the administration, it can reduce all those things. So decentralized finance, whereby you can essentially have the same level of interaction as you would with a major international bank, but with a small local source, is a big thing. So it's fueling microfinance in terms of entrepreneurs, in terms of business development, those kinds of things. So even the course that you were talking about there, that kind of coastal tourism and development, they're the ideal kind of situations for decentralized finance, where small amounts of money can be made available for verified purposes. Media verification is another big one. So AI in conjunction with blockchain is doing a lot of media verification. So verifying sources that something is what it says it is. There's been a huge amount of misinformation, disinformation, whereby social media in particular has had large corporates and trusted brands applied to disinformation campaigns. So it's happened to BBC, it's happened to CNN, it's happened to a lot of things. Sorry? Exactly, yes. I'm sure we've all seen him in his Balenciaga coat, which he may or may not have had. But the point is, it's often backed up by a brand that is recognizable. So there's a lot of work out there now at the moment to combine AI for verification purposes that's then stored on a blockchain so that once it's verified, it's there for everyone to reference. Web3 is another major element. Has anyone heard of Web3? Very good, very good. So, not for a few, but that's interesting. That's interesting. So, very, very simply, Web3 is a development of the internet where the end user retains full control of their own identity, but also the content that they produce, and can have a system of reward for the content they produce. So instead of you going on a platform like Facebook, and others are available, and putting up content that becomes theirs to monetize, to mine the information for, plus your personal details that they monetize as well. In a Web3 system, you retain control of that, and you decide what a company like that can use and what they can't, and what your reward will be for it. So Web3 is still only kind of emerging, but it's being taken as a blueprint for how the web can work in the future. So NFTs, non-fungible tokens, these are being used as well. Now, when people think of NFTs, they think of pictures of apes and things like that. You might have heard them in terms of artwork, and that is true, that all does happen. However, there are very, very practical applications for NFTs as well. If you think of an NFT as a deed, as opposed to the thing itself, that's probably a better way to conceptualize it. So say, for example, the large auction houses, the likes of Christie's and Sotheby's and things like that, as they deal with objects that are not necessarily artworks, but say a very good example is a mass-produced item that is of value because of what it was used for or who it was used by. There's a very good example. The astronaut Buzz Aldrin, one of the watches that he wore on the moon, right? It was digitally scanned, so a complete 3D scan, and that 3D scan became the basis of a digital identity that is now an NFT. So the Smithsonian Museum, when it's showing his watch or when it's sending it out for somebody else to show it, the actual administrative record of it is the NFT. So it stays in a glass case until all the admin work is done with this digital certificate, and only then does the object itself move. So it's a deed that represents it through the entire digital process until such time as the physical object needs to move. And that's all done on a blockchain. So NFTs are a big element of it. The metaverse as well. Now the metaverse as a topic has kind of fallen away a lot recently, and after a lot of initial hype. But the kind of concepts behind it are persisting. And again, one of the things that they're talking about is that the metaverse being a kind of a 3D visualization of the web, that you will experience as much as use. Again, they're open systems, and they're more than likely going to be based around blockchains as a base level of the technologies that allow them to interact with each other in particular. Biodiversity monitoring is another one, again, because of the kind of the nature of the way the information comes in, and sometimes the controversial nature of it too. So along with carbon management, biodiversity monitoring, because of the kind of large open nature of the blockchain's capability for storage is ideal for it. So where can I learn about blockchain? Locally, ICT SkillNet is one of the government agencies that provides a lot of information around that. They were directly involved in the first Masters in Blockchain program that was developed here for DCU, but there's also one now in Cork University, there's one in the ATU out of Galway, the Atlantic Technological University, there's lots around. IBM have a free skills build program where they have a whole blockchain channel as well. The University of Nicosia was one of the first to actually have a blockchain masters in the world, but they have these MOOCs, large self-serve courses that can build micro-credentials, essentially, depending on the direction you want to go in. They're an ideal kind of starter element because you can go in and do the basics, and then you can start to branch off into lots of specialisms as well. Harvard University have a lot of online resources as well that they've brought together and made free. The Udemy platform generally, which is another kind of online self-education course, has a large amount of blockchain. Alchemy is quite similar, but it's a bit more specialized in terms of the blockchain space. The Blockchain Training Alliance is a good source as well. So, okay. I've thrown a lot of information at you. I've used a lot of terms. I've hopefully explained all of the acronyms, but if anybody has any questions, certainly.
Yeah, so thanks for that. It was really clear. I kind of feel bad because I have a question from early on.
Sure, yeah, shoot.
So when you defined blockchain, you said there's a bunch of actions, right?
Yes.
And you went on further, obviously, and explained that. So the takeaway that I have is that it's kind of the old-fashioned language, but it's kind of write once and read many is the
yes,
thing, right?
Absolutely.
So my question then though is, like, is there a list of the actions that you were referring to in the definition? Like, is there a whole bunch of things you can do?
Yes. So as you saw there, the applications of a blockchain system are growing hugely. So the criteria for why or whether a block gets added to the chain or not just depends on the application of the blockchain in the first place. So let's say a health record, or actually credentials management is a really good one. Slovenia have a credentials management system for certified professionals. So let's say you are a certified professional, a chartered accountant, okay? When you get your certificate, you go and you register on the blockchain. So there's a set of criteria there for who you are, your age, whatever, the certificate you got, where you got it from, when you got it, blah, blah, blah. So once all those criteria are met, that goes through the consensus mechanism. It says, yeah, okay, all the bits are there. Form a new block for Dermot. He's got his certification. He goes on to the block. That means then that you can go to any part of the EU. They can go back and they can check that you are who you say you are, and that the certification that you hold is on that blockchain. It's immutable, it's secure, and it's available to everyone. So that's a really good application of it, and that's why one of the big one of the big prospects for blockchain is to underlie public services generally. Because it's one of those things. The government CIO here, Barry Lowry, he constantly says that he wants a system whereby we interact with government digitally by telling them once and they use it many times. So instead of having to fill out the same form for welfare, for tax, for health, for anything else.
I love the government, by the way, but anyway.
Yeah, so, but as a basis for it, like that's it. So a service coming into that blockchain only takes what they need. So when revenue comes in, they're not going to look at your health records because it's not relevant to them, you know. So That's what you're talking about. So absolutely, it's a read or a write once, read many times system, but the mechanism for forming a block will depend on the application of the blockchain in the first place.
I have more, but maybe somebody else has questions.
Anybody else? Yeah.
You're talking about private blockchains. How does that work if there's not an identity?
Well, you see, depending on the application of the blockchain, then it is generally a zero trust system. But in a private application, you have control over all aspects of it. So it can be an identity-based system in a private application. So, for example, if you had something, say, whereby you were controlling credentials specifically for one application. An example might be if you work in the events industry, there are certifications for rigging for stages that you have to recertify every year. So if you don't have a record of that, then you just can't play. So in an instance like that, if you were to use a blockchain system there, that's a completely private system. So it doesn't need to be open to the general public. So you could have it as an ID login based system there, because the blocks would be added to each time. So even though you would be the same person going in each time, the new block would be added for your credentials for this year, and it would be based purely on your identity. So in a private application, you have control over how you interact with it. And if you want it to be purely identity-based, you can do that. But in the big public systems like Bitcoin, then that's not the way they work. They work on a zero-trust system where there's no physical identities in there. There are merely things like wallets and secure IDs. Absolutely, yeah. So, and again then, so a consortium system might work with elements of both as well. So again, say the Maersk logistics system, they have to be able to let, say, shipping companies come in and out of that as they take up, say, subcontracts, or as they outsource elements of what they do. So they would have to have a system whereby they can incorporate people for access to it and then remove them as well as necessary, So it all depends. In a private system, you can set it up any way you want, but the fundamental characteristics of the blockchain remain the same in terms of secure, immutable, and the consensus mechanism to add a block in the first place.
Yeah, so that's the thing. Would there be a... No, as I was going, would there be a reason to be private, but I suppose if it's not speakable?
Well, it just depends. It just depends on the application. Sometimes in a commercial setting, it could be, it could effectively be a private blockchain. But then, say, you could have, say, the system of health records. That would have to work in a different way. So that wouldn't be completely open, because you don't want everybody having access to medical records, even if you can't put a name to a record. So it really just, it's very much horses for courses. The sector in which it's being applied, or the service in which it's being applied, determines how the blockchain will work. But the fundamental characteristics of it remain the same. Okay, do you want to come back in with
well, one thing that's occurred to me since actually is like about the kind of governance. Like if I'm a rubbish programmer, which I am, and I times it hard and I decide I write a blockchain and I go to market and pretend it's good, right? Like, how does anybody know that the claim that I have that this is an actual fully fledged blockchain is true? Because everybody's depending on trust for that, as I understand it.
That's a reasonable question, but as we said previously, the fundamental qualities of it are that there's a consensus mechanism, there's a level of security, and there's a level of immutability. If you haven't defined why some of those elements mightn't be as you would expect, then people are going to say this is not actually a blockchain. Because you see, the point is that there are different ways, like it is essentially a system of record. It is a form of a database, except it's decentralized across nodes.
It's kind of a wisdom of the
So,
aspect.
yeah, so essentially in just the same way as, you know, you could paint a cow and call it a giraffe, you know. As soon as somebody starts interacting with it, they're going to realize it's not a giraffe, you know. So the point is that when you say this is a blockchain-based system to do X, when people start to interact with it, if your specifications and your documentation as to how to interact with it aren't consistent with what would be expected as a characteristics of a blockchain, that will become apparent very quickly. Yeah, but again, you see, zero trust is not just a phrase.
Yeah.
Zero trust has a set of criteria with it. And if they're not met, it's not zero trust, you know? So zero trust proofs mean that you're not even making a claim. You are simply presenting a piece of data. And a zero trust proof is applied against it. And if all elements of the proof do not check out, it doesn't progress further. That's the whole point of zero trust. So it's a mathematical algorithm that actually says whether it passes or not. You know, so in that same way, you can claim something is blockchain, but it will become very apparent very quickly if it is or it isn't. That said, you always, you know, trust but verify. You know, that particularly with these scams, you see, because the whole point of this is disintermediation. There's no middleman between you and what you're dealing with. If there is, that rings an alarm bell. You know, so, but the point then is self-custody is what they call it. It's where you are entirely in control of your own identity and your own digital wallet. So that's where things arise, and that's where the usability element comes in. There's an awful lot of work being done on user interface and user experience to try and make it easier, to make it more familiar. So there are systems out there. There are things like MetaMask. There's other things that are trying to get people or get services more usable and get it more familiar to people. So say, for example, Revolut have now added digital wallets for holding cryptocurrencies and trading them as well. You know, so again, it's a familiar interface, a trusted brand, and it's something that's trying to make it more familiar and usable every day. But always, with any of these things, trust but verify.
In the future, is it the case then that there wouldn't be currency, like physical currency in the banks? Or will that always exist?
I would say there will always be currency. So at the moment, there are things called CDBCs, central bank digital currencies. I think at the last count, there were 136 central banks around the world, including the European Central Bank, working on digital currencies. And there's already one in China, and it was used specifically in COVID to have specific COVID reliefs made available to people. So what you will see is that in the future, there will be digital currencies, there will be central bank digital currencies, there will be things called tokens, which are kind of halfway in between, and then there will be, you know, the Bitcoins and the established ones as well. What you're going to see is, again, to use the term horses for courses, there are things that digital currencies are really very good at. So big international settlements, they are excellent. They can make international settlements go from, at the moment there's a thing called T+2. So if you're doing a major share trade, so let's say when you have something like a major international acquisition, when the actual transactions to make that happen are going through, and you have something like 6 million shares in a 10 million share organization are changing hands, that can take up to 2 days to actually settle from one institution to another. That should be instantaneous. So digital currencies and what they call asset tokenization whereby those 6 million physical shares get turned into a digital token in much the same way as the digital representation of the object for the Smithsonian. A digital asset can be traded in digital time. So those settlements can go from 2 days to 2 milliseconds, you know. So that's what's happening. So a central bank digital currency is much the same. So when you hear about something like quantitative easing, whereby an institutional bank gets 10 billion in funding for balancing its books in terms of supporting an economy from a central bank, those kinds of things are where a digital currency comes in. That can be done instantaneously, you know. But then right down to kind of retail as well. I was actually talking to a friend just recently, and they were trying to send money directly to a friend in Japan who was going to buy something for them in a local market. So this was a local market that was essentially being circulated, I think it was by Facebook again, other platforms are available. And the guy went, I have a friend in Japan, I really want that. So they couldn't buy it directly, so they got somebody to, but actually sending them the $40 or $50 to do it was a hassle, you know? So those kinds of things, that's where digital currencies really come in. Because even now, IBAN to IBAN can take 3-5 days, even though it's supposed to be a digital system. So what you'll see is a set of roles and a set of characteristics that for these kinds of transactions, fiat currency will be the standard. For a whole other set of transactions, either central bank digital currencies or pure digital currencies will be the way to go. And then there'll be a whole other section, the Wild West as well. So definitely it's been taken up by the institutions, and in the future you'll see a spectrum of applications for it. Anybody else? Okay, I've probably talked enough. So as I said, don't worry too much about the notes and things like that. We'll distribute via your registration if anybody wants the slides and wants to follow up on the references or the resources there. Okay? All right, thank you very much for your attention.
Okay, so back to me. So as Paul was saying, there are a lot of sources to learn about blockchain, but now you have one more, my course, beside course. It's also an MOOC course, a massive open online course, was what Paul was trying to say before. This is also in modules, so it comes from basic knowledge about blockchain applied to finance, and by the end you have a certificate, exactly as Paul was explaining about the other course he was talking about. So beside is an Erasmus project, the ones I've talked before, and the objective of this project, of course, is to develop an e-course that in this case trains young professionals, but I mean it's open to anyone that wants to know a bit more about blockchain, specifically in the financial area, in new technologies and digital tools. So this course covers all the essentials of blockchain concepts, such as cryptocurrency, smart contracts, digital assets, tokenization, regulation. I mean, most of them are concepts that Paul already mentioned here today. You need no knowledge, as I already said. This particular project have also another aim, which is to also train trainers to deliver this course to their students, okay? So you will see the course that you can take on your own, it's online, but you will also see the part for the trainers if anyone wants to deliver this to their students to better understand this course. So just a bit of an overview of the course. The content of this course was developed by the Frankfurt School of Finance and Management. It's one of the partners in this project, alongside F6S and others. It issues a certificate when you complete the course. It's divided into 3 modules, so a financial module, a digital module, and a technical module. It has 5 units per module, and each module should take around 30 to 40 minutes. So it should take, the whole course should take about 6 to 8 hours, depending on the pace you do it. Okay, going a bit into the module design. So every module, each module has like a introduction for context on that subject. Then you have more deep content on the subject, an interactive assignment if you want to do it by your own, more research to, upscale what you are learning. Then again, more deep content on the topic, and then a quiz, a self-evaluation quiz it's a multiple choice quiz that will tell you right away if you got it wrong or not. You can take it as many times as you need, and if you complete the quiz, then it will issue the certificate by the end. Okay, we have 3 modules, as I already mentioned. The financial one that covers cryptocurrencies, blockchain technology, use case development, portfolio management, and then has the assessment by the end. Here you can see a bit more about the topics, the specific topics that you have. But then again, this is also about the topics. This is all about the topics I already explained. So this is the beginning. This is the basic concepts about blockchain applied to finance. Okay, so you have an understanding. And by the end of the module, of course, the 10 multiple question quiz. The second course the second module. Is the digital one, which focuses on tokenization, regulation, blockchain payments, Oracle data, GDPR issues. So it's one step further in the concept and in advancing your knowledge about blockchain, actually. Here, more in depth. So tokenization, security, tokens, digital payments. Here you have on the third module self-learning asset for you, and data storage, GDPR, all of this. And then we go into the third module, which is the technical one, that goes more into wallets, security, interacting with Web3 that Paul also mentioned, smart contracts, and all of that. Again, a bit more about the specific topics that each topic talks about. Here you have Ethereum, wallet, security, token creation. This assignment is also, it's actually a tutorial that you can do on your own, okay, to try to replicate this, to try to do this on your own. And then, again, the quiz by the end. So, when you finish, you get a certificate like this with your name, not Cedric, okay, it will be your own name. This is one of our partners that completed the course. And you'll get a certificate as you have these competencies and as you did this type of course in blockchain. So I will show it to you now, okay, if you want to scan it. First, this course is translated into 5 different languages, okay? So it's not just in English. So if you know anyone that is more comfortable, let's say, with French or Dutch or Italian, okay, the course is fully translated in all of these 5 languages that you can see here, okay? Then if you click on guide, this is the guide for the trainers, for the teachers, for the VET centers, okay? It's to understand, it's probably not your case, this is to better understand the scope of the course and how they can better deliver it to their students. Syllabus is the definition of the course, okay? It's the content of the course. Is the course divided by modules, learning units, types, contents, and what type of learning outcomes you should get when you take these units. It's basically the blueprint of our course. So I'm in progress, I haven't finished. See, you have a progress bar on the top. And you go here, I started module 1. Let's go to module 2. Okay, and it takes you to the content. And here, the first unit, it's just context, so you see this as text. Okay, and it's the context of this unit. And if I go back, module 2, unit 2 already shows in a different way because we wanted this to not be boring, okay, not be so boring, so we made it in different ways. It's kind of slideshow, and you have a lot of images, and you have the text here, so it's made to not be, you know, boring. You can scan through it. Then you have the, you know, self-taught activities. This is something for you to develop your capacities on this. You have the background, you have the task, and you can complete this by yourself. This is not evaluated, okay? It's something for you to develop more the capacities on this topic. And then the last is the quiz, okay? Here you have 10 multiple questions. You can go back and forth on it. I can jump to the 5th question. I can go back to the 2nd question. I can, no, I already did this, but now I go to the 4th, okay? And then you end your quiz, and it tells you right away if you got everything right or everything wrong. So this is very simple. It's a very intuitive course. I will just finish the questions with whatever questions to show you how it looks like by the end. Okay. I'm not reading the questions, so I probably will fail everything. It's just for you to have an idea that you can then quiz summary. Okay, finish quiz. And it's okay, so even doing it randomly, I managed to have 3 right. You need to restart, okay? You need to have at least 75% of the answers correct. And you could restart the quiz. Or you could then go back and go into a different module. So this is very intuitive, okay? This is very, you can learn at your own pace. The progress bar will tell you how far have you come in the course or in the module. And by the end, you have the certificate. So, and then again, no knowledge, no prior knowledge is needed, and it goes from basic concepts to more advanced ones. So just go to mooc.besideproject.eu, and you have here our amazing blockchain use cases in digital finance. So I hope this is useful for you, and if you have anyone that might be interested in learning, you know, the basics of blockchain from the very beginning, please share with them. And even for teachers, I see you are a teacher. So this is very interesting to students, to young people, also to learn more about these questions, financial questions around blockchain. Any questions?
How long does it take to
the course to complete? Around 6 to 8 hours. It depends on your pace. But each module should take you around 30 to 40 minutes. Okay. Sorry, each unit. Each module has 5 units. So, but then again, there is no time constraint on this, and you can take the quizzes as many times as you want or as you need. Okay, so if there are no further questions, no, I would like to thank you very much to have been here today. So if you want to scan to later remember, feel free to do so, and feel free to take the course and to tell your friends and students if you have any. Okay, thank you so much for being here today. Thank you.